Good afternoon, ladies and gentlemen. My name is Bruce Boyd. I'm a Director of Precision Contracting Services. Today I have with me Tim Cessna and Juan Oro from our FiberTrak Services Group. Precision is a fiber optic integration installation firm. We build government-wide and metropolitan area networks throughout the southeastern United States, focusing on, again, government, less of the private networks. We've been in business now 20 years performing these services, building these metropolitan area networks for various state and local governments. And over that period of time, as a gentleman before us had talked about how it's important to locate these services, we have recognized that it was just as important for our customers to have an intelligent, intuitive data. So we created a services group called FiberTrak Services. And investigating all of the tools out there to properly and accurately document all of our clients' assets, we chose Bentley Communication and MicroStation as the core for our platform. We believe it's certainly is the most robust, flexible tool that we need. Some of the networks that we've designed in the last, didn't go down, over the past couple of years since we started this group, are the entire state of South Carolina's Department of Transportation infrastructure, over 300 miles and 400 some devices placed throughout. Recently, we're awarded the Florida Department of Transportation's District 4 district-wide infrastructure documentation, as most of the Bentley users are well aware that they're based around MicroStation products. This is a big coup because we've taken it from a Bentley competitor. And they basically have recognized the successes that we've had at the various other county and cities throughout the state of Florida, where we've actually mapped and been able to provide intuitive documentation for all these other cities and counties. Growing every day. In between the sessions here, I just got a notification that we've been chosen for the city of Marietta, Georgia. At the core philosophy of our FiberTrak services and providing the documentation is turning what had been in the past static or unintuitive data that our governmental clients had been given into information. That's what they need to be able to operate and maintain these what we call intelligent transportation systems you see for the Department of Transportation, or for an IT department running the healthcare system and the school board within a given county. Our Bentley Communications and MicroStation, again, is the core for our solutions, and we're currently migrating from the old V8.5 to V8i, and we know that'll further enhance our ability to do it through web browsing and things. In the Port St. Lucie project that we've presented, we were a design-build contractor, and any opportunity that we get to do a design-build metropolitan area fiber optic network creates many obstacles, because you have multiple different end user groups with differing agendas and goals that our professionalism and what we do very well is bringing them together to develop a common set of criteria and attributes that we start to develop in the network documentation model. In the Port St. Lucie project, we have to establish diverse network routing to provide the highest quality of service while also accommodating future growth. Governmental networks are somewhat unique, such as road projects. They tend to go in segments or stages as funding comes about. So being able to do that and go from project to project or through the life cycle using Bentley Comms is a great asset. We provide additional data services to independent departments throughout the city, because many of these wide area networks have requirements to where we're using, again, like I said, multiple departments. So the ability within the communications platform to identify circuit names and elements by department or by user group allows us, when we do bill of materials and asset allocations by department, to be able to document and track that. The core Bentley products also provide us a means to communicate critical information back across city and county borders as we marry project to project between state, local, and county governments, all using the MicroStation platform. It allows us to design a network that is both capable of being constructed on budget and within time. Additionally, for the Port St. Lucie project, We have multiple user groups, as I mentioned. Some of these are the client end users, and they're, of course, interested in the GIS locates. They want to protect their asset. The civil engineers are working in the microstation drawings, and they're interested in getting them a layer that they can put into a bid project or what have you. The network engineer is clearly focused on the attribute data taken from our Esri products, incorporated through our database management that we do as Intuitive, to provide them bill of materials through the comms products that are really robust. And of course, back to the prime contractors that all they want to do is make money and give static as-built to somebody. We tend to be the low man on the totem pole as well. We start at the top on the design and act as the end as a subcontractor, actually turning on and splicing and turning up the electronics for these governmental entities. Typically, some of the historical dilemmas that we run into in designing these, of course, are the multiple goals of the disciplines, and typically, when they have ended a project, they've come up with static, non-living documentation that we've been engaged to now hire and incorporate into intuitive elements that we can provide onto people such as the firm before us that does the locating and additional asset management. Part of our problem resolution that we've come to over the years is by implementing the Bentley Communications, we've been able to centralize and standardize our clients' documentation so that we cover all of the goals of the various stakeholders in the job. That has been very well recognized and had never been actually addressed in the past by the 3 or 4 competing products that are out there. Our ability to create GIS Foundation for CAD and database exchange platform and features for documentation where we implement, we're able to attach industry compliant standardized design criteria. And, we're also able to produce geospatially referenced standardized plan sets. We create detailed network configurations and connectivity models that go above and beyond your typical Visio drawings. And we're able to support all of the GPS locating and reporting assets for all wide area network asset management. We take our intuitive databases and we integrate them, of course, with additional raster images, XLs, text documents, so that when they're given a product or we call it our FiberTrak model for the particular client, it's very inclusive all the way from Esri GIS attribute data collection all the way through to the live data model that we host for them and allow them remote access on. We call this our FiberTrak approach, and in that approach, it's intuitive. We draw on all of our years of constructability, procedures, and knowledge, what we know about network administrators and what their needs are to maintain and operate an intuitive network. We call that our life cycle approach. We come out with our clients and we help them understand that to get from their goals all the way back from the design through construction, as building, I'll go on to the model, through the operation and maintenance, and then back to upgrading, because a network is a live and intuitive asset. They're continually managing, modifying, updating, and having to protect, as the gentleman previous. Part of the goals of our is identifying the goals of our clients, as I mentioned, and get them to understand and implement as we establish the network component and attributes, which is the core and some of the initial activities that we try to do, so we can track and accurately complete their data collection. In addition, we're able to get data collection geared towards how the data will be processed and sustained in repeatable information, such as acquiring our duct sizes, the cable fills, the type and style of conduit plants, fiber configurations, counts, types, and as far as the cables, the configurations, the entry points, the devices, and the closures. Last week in Fort Lauderdale alone, they had a damage where the county did not have records back proceeding to where they knew what cables were in which conduits, which supported which departments. This is the type of effort that we go out and reconstruct in an as-built configuration as opposed to a pre-designed configuration. Some of our intuitive methodologies that we've developed over the last couple of years of implementing Bentley Communications for this effort is the ability to port map in inside plant equipment editor so that we can turn around and develop outside plant engineering calculations and incorporate the two modules together. By doing so, we're able to have a single database element built in the equipment editor whereby we can accommodate multiple global design features and functions by changing its port mapping, achieving the following design functions within a project. Once we map it, we're actually able to perform the engineering calculations so that we can tell a customer what power of laser he may need in his Cisco router or what have you. Beyond that, we're then able to take his engineering calculations performed and attach those to a specific device, populate it with IP and MAC address information for their bill of materials, and then we're able to convert the ports that are mapped and identified to an optical system name so that we can track from inside to outside plant. In the comms product, you can typically go from outside plant to outside plant passive device. These gentlemen, we've created a way to port map through an active component. Thereby, if it is the hospital administration department, we can query his entire system and see what devices he has attached to what fibers. It's a unique application of the Bentley Comms process. Additional innovative methodologies we've had is in the building these ISP devices as components reflects an accurate bill of material. It allows us, as again in governmental networks, or sometimes built in stages, they may only populate a certain level of a fiber cabinet or a certain Cisco router with certain amounts of gigabit interface, optical transmitters, at a particular time. Other particular products, not the Bentley Com, are very static. Once it is placed, it is locked in. One big benefit that we've built around by creating this method within Bentley is to be able to integrate them over time, place additional active lasers or place additional components within a device element. Additionally, in the inside plant setup modules, we use devices as racks. By making this small amount of conversion, we're actually able to get more flexibility. Instead of being locked into placing in a 19-inch EIA standard rack, we're actually able to place vertically or in a given cabinet an element rendering that is more geometrically and geospatially accurate for non-19-inch rack placements. An additional innovative method that we've developed over time is the ability to interface Oracle and the Access database by referencing our MS Link cells, facilitating data exchange for custom reporting. And what we've done here is by extracting the comms data and interfacing with Oracle, we're able to import this data into Access databases or other models to create relationships and special queries and reports. An example for the Port St. Lucie project was we were able to report on the number of splices that were in a given splice closure for actual count and bill of materials reporting for developing a cost budget for the project. Additionally, with the bill of materials reports on the outside plant cabinets for the city, we're able to document assets by department. And in the previous cabinet that he had shown, one benefit that they told us by populating all of the elements within the cabinet in the Bentley Comms, they had a traffic knockdown. Well, the ability for that traffic engineer to print the bill of material immediately and say it's $37,000 and get his money from an insurance company within a day or two was much more. It's taken them up to 6 months just to go back and recreate the data of what they had, these assets that they had, let alone request compensation. Additional innovative methodology that we've deployed is the ability to toggle a script between Oracle and Comms config files that establish on a server or client. This is more of an operational method. where we're able to version our comms model for mobile and design versioning capability to eliminate the need for virtual machines. What we've done there is the FiberTrak group we've processed uses a server workstation configuration, providing access to the server of the comms oracle while populating the network design parameters. It utilizes a client workstation of the comms oracle network model to work in the versioning of the design process. It's conceived to help manage our design versioning process as we were on the older versions, and to allow our field services personnel to get data remotely while they're on mobile laptops. We're currently in converting to the 8i, and that will certainly help those processes out. Another method that we've enhanced on the Bentley Comms is the ability to interface the DGN and GPS into the Google Maps, similar to what the previous gentleman had done. Our Bentley software interface to the Oracle database supports collaborating. Is this where you need to go down? The data from various sources. Our clients typically have multiple applications that we're required to provide or reference into or provide a database module to. In that, we have to provide certain database, we modify certain database elements and import them into those particular applications for the clients. By employing this interface, PCS is able to convey the information from Bentley Comms in the various models so that we can provide asset installation crews, navigation, and materials management. This is how we provide our GPS, where we overlay the DGN plans into Google, and we apply the GPS real-time locator, such as they've done in the past. We're able to have the DOT maintenance personnel tracked, or we track our people, and they're able to see and drive out to a site, and then they would actually be able, if we were actually live on our system, pull up our mobile version and click into that plan set. And for those of you who know comms, click into the line, see the intuitive database, find out what the fiber is connected to, find out what the device is connected to, all by being mobile on a Google-based GPS interface. We know that's pretty intuitive, and the states are starting to like that, till they know where their maintenance personnel are. Some additional intuitive methodologies that we've implemented into the Bentley Comms for our customers is, the ability to deliver in variable formats, as I mentioned, is a requirement for us to cater to these different departments, but with the core philosophy of keeping it reliable, repeatable, and consistent, complete information that they had not had in previous engagements. We pioneered a DGN reference structure that uses base files that are updated by comms reporting features, standard comms reporting features. When pushed out to the layouts, we're then able to create a common base file, and as we modify over time, again in segments as these projects are done, we're able to ripple those modifications and not have to redraw any CAD files. We just update the terminating line text and stuff by pushing it out right from the base file. Some of these examples were our digital routing for geometric placement, our fiber connectivity schematics that we provide, detailed fiber splice schematics for various locations when they start to get 4 and 5 and 6 cables coming, and 4 and 5 and 6 users within each cable. Physical link schematics showing their splice connectivity through the fiber plant as it's routed. Makes maintenance and operation a little easier for IT people. Physical raster image connections, as I mentioned previously, for their further documenting their asset management. Civil details for duct, manhole, and raceway modules. And lastly, the geographic ring topologies for the IT managers so that they can see where their assets are. And of course, all of these would be live in the active model, where you can drill in and go and see and query into particular assets and fibers. The Bentley Comms allows us to export out through their splice schematics and fiber connectivity circuit trace models. We use circuit traces to develop these models, and then we just expand on the CAD files. Additionally, our FiberTrak services, we host remote desktop for our clients, remote clients, so that they can come in and perform red lines capability and see, as I mentioned, off their mobile devices. We also provide remote training through WebEx as well as remotely to their contract engineers. And one of our last innovations implemented into the Bentley Comms product is we established what we call that life cycle approach. It allows us to establish common centralized place for all information throughout a given project. And in that network design, we have checks and balances between the GIS system and the comms model to be able to make sure all the connectivity is accurate and complete. It offers us a wide range of as-built formats by being able to export out the database elements, and we use data exchange features to the various other models that we may need to populate depending on what the client requires. It gives us a GIS model that can be hosted and maintained in a manner that's consistent, repeatable, and provides instant updates that we ripple through their entire project as we continue to do the remote updates. The Department of Transportation, in doing government work, as you may imagine, is somewhat hard to quantify in some regards. So I pulled one slide that was recently in what we call the Sun Guide report for the Florida Department of Transportation, where they reported their benefits to operating an improved quality of service and return on the network investment. The network management activity was representing the average time to analyze and isolate a network failure was improved by 83% in 1 year. The time to change the network configuration from manual to automation was 57%. The enhanced revenue collection, this was talking about toll collections. We run all of the infrastructure for the Florida Sun Guide Tolls Department of Communications, was increased by 5%. We increased the reliability and usage, therefore fault prevention, by 10%, locating. Also had the number of resources required to change the network configuration reduced by 33%. They were doing everything by hand red lines. We increased the operations center resource requirements by 40%, or reduced the resource requirements by 40%. They have network operations centers, and they were able to reduce staff. And additionally, the average reduction of order processing and equipment programming errors was reduced by 11%. It's clear that the knowledge of where all the components are of networks in today's environment, how they are used, when they will be obsolete, and what's their capacity is crucial to maintaining a quality of service and return on network investment. That's evidenced more so by the very recent recognition by our president for the funding of the NTIA's BTOP program that was just announced in September to the tune of $4.7 billion. It's going to be providing grants to support the deployment of broadband infrastructure in underserved and unserved areas to enhance broadband capacity. Within the BTOP and the ARA, the American Reinvestment and Recovery Act, that he's currently deployed, is another factor. The National Association of Telecom Officers and Advisors, over the long-term broadband deployment, helps virtually every economic sector. For every dollar invested in the broadband economy sees a tenfold return on the investment. For this recent study, the economic impact stimulating broadband nationally suggests that a national program that invests broadband penetration by more than 7% will yield a $135 billion positive impact on our economy and 2.4 million jobs. That's over a 25% return. Additionally, the State Broadband Data and Development Grant Program is matching a grant program that implements and joint purposes for the ARA and the Broadband Data Improvement Act. This program is currently providing grants to assist states and its designees in gathering and verifying state-specific data on available speed, location, technology, and type of broadband services. Exactly what we do. Lastly, the data they collect and compile will also be used to develop publicly available statewide broadband maps to inform comprehensive, interactive, and searchable national broadband maps that the NTIA is required by the Recovery Act to complete in 2011. PCS is right in the middle of one of the hottest network documentation efforts, and we're using Bentley MicroStation and Comms as the core. We believe in it. It's proved us very well. And it allows us to turn non-intelligent data into information. Thank you.